So problem 37, we have a single force acting on a 3 kilogram particle-like object whose position is given by this equation. So with x in meters and t in seconds, find the work done on the object by the force from 0 to 4 seconds. So a couple things come to mind here. I know that work is force times distance when the force is constant. So if I look at this problem, I can decide right away if that is going to work for me. Can I find out what the force is and then multiply it and then find out what the displacement is and multiply them together? And hopefully you recognize, because where my pencil is pointing right now, the answer to that question is no. Because remember, the equation for force times distance is only valid for a constant force. And how do I know that a constant force is not acting on this particle? Well, if you remember, when we look at the position function as a function of time, we know that the acceleration is constant if the highest power on t is 2. But here we see the highest power on t is 3. So that tells me that this is not constant acceleration, which means it's not a constant force, right? F equals ma. If my acceleration is not constant, my force is not constant. So I am not able to just do force times displacement. I'm going to have to rely on something else. So I think to myself, the work done on the object, okay, I know the work done is both the area under the force as a function of position graph, or I can find it with the work kinetic energy theorem. And it turns out we can do it either way for this problem. So let me share with you the more direct way, or the quicker way, I should say, and that's the work kinetic energy theorem. Okay, so they told me the mass. I know the work kinetic energy theorem is the difference in kinetic energies. So I need to know the mass, which I do know, but I need to know the velocities at 0 seconds and at 4 seconds. So from this equation, we know that since it's with respect to time, I can take the derivative of dx dt, and that gives me the velocity. Plug in my values for time, 4 seconds and 0 seconds, and I come up with my values for velocity at those two locations, and now I can plug them into my change in kinetic energy equation and quickly come up with my answer that the work done from 0 to 4 seconds was positive 528 joules. And that's my answer. But let's just say you wanted to do it the other way. It's a little bit more work, but I want to show you that it does work. Haha, no pun intended. Okay, so here's what I'm trying to figure out. The area under the force as a function of position graph, right? That's what this means in math talk. Okay? So I need to find the force. How do I find that? Well, if I take the derivative of the position function 2 times, right, that gives me the acceleration. And then if I multiply that by the mass, that was given to me as 3 kilograms, so 3 times 8 is 24, 3 times 6 is 18. There is my equation for force. And as you see, it is a function of time. Like we decided before, the force is not constant. It is changing with time. And then, what is my dx? Well, dx dt is this expression here. So dx is, I move the dt to the other side, and this is what I get for dx. So what happens here is, my original equation was integrating with respect to x, but now when I replace dx with all of this, now I'm integrating with respect to t. And that works out well because my force is a function of t, so I can integrate this with respect to t. So I didn't do the integration yet. I multiplied everything out. You see, it's a lot of algebra here. Once I got to this, now I can integrate, right? Negative 24 is negative 24t. 64t is 64 over 2t squared, and so on. You can see all these. I've just integrated them. And now I plug in 4, and then when you plug in 0, you notice they all drop away nicely. So I don't have to, otherwise I would have a minus and a whole nother one of these lines using this term, or this value. But it's 0, so they all go to 0. And now I can add them all up, and you see I get the same answer. So that was quite a lengthy process, a lot of algebra, but just to show you, It did work.